to asym code, don't forget to smash that like button and subscribe so you never miss an update. More coding goodness is coming soon. HDF5, Hierarchical Data Format version 5, is a file format designed for storing and organizing large amounts of data, and PyTables is a Python library built on top of HDF5 that makes it easy to manage structured datasets efficiently. Using PyTables, you can define custom table schemas, like a database, store complex hierarchical data in groups and tables, and perform fast read/write operations. In a typical workflow, you create an HDF5 file, define a table structure using a Python class, insert rows of data, and then retrieve that data efficiently. PyTables supports compression, querying, and indexing, making it ideal for scientific, analytical, or large-scale structured data applications. First, we import the PyTables library, which provides tools to work with HDF5 files. We define a structure for the table rows, similar to defining a schema in a database. Each person will have a name stored as a string of up to 64 characters. We'll also store their age as a 32-bit integer. Create a new HDF5 file, or overwrite if it already exists. This file will be used to store our data. Inside the HDF5 file, we create a group to organize related tables or datasets. Now we create a table in the group using our previously defined person structure. Get a reference to a row object, which we'll use to fill in data. Fill in the first person's data. Add this row to the table. Fill in the second person's data. Add this row to the table. Once all data is added, We must flush the table to ensure data is written to disk. Let's now read back the data from the table. Decode the name. PyTables stores strings as bytes, and print each person's data. Finally, we close the HDF5 file to free up system resources. Now run our code. That's it for today, folks. Please like, comment, and subscribe for more.